Hi, hello everyone. Today we'll discuss regular languages, which is the input of finite automata, and also it recognized by finite automata or any of the finite automata its type. Let us see what is the definition of regular language. Regular language is the language that can recognize by finite state machine or also called as a finite automata. Sometimes we can call this finite automata or finite state machine. Let us see what is the best example for finite state machine which accepted by regular language. So there is an example is A star B star. A star B star, it regenerate the language either as epsilon or any number of A's followed by any number of B's. Then how do you construct finite state machine? This is the best example. Look at this. There is any number of A's which accept that is A star in the state 1. This should be it is only one A is accepted, or it may be is accept there is a epsilon or any number of A, and followed by there is a B. So in this case there is a B will be there which accept B and go to the next state, that is 2. That is also accept followed any number of B's. That means you have create loop over state 2. In this case there are two final state, the state 1 and state 2. Why? Because it may be any point of time B can be absent and any point of time A can be absent, that either it can be terminated in A, one state, or terminated at 2 state. Okay. So what is that state 3? State 3, it will lead after that, after B star, it can comes any A's and B's. It is a immaterial of the machine. It can treat that as a dead state. So followed by any A's and B's it come, need not to worry about it. Okay. This is a complete DFA or finite state machine. So that is a narration of the topic you need to start on finite automata or finite state machine, how the regular language represented in finite state machine. Let us see the next finite automata. What is the definition of finite automata? The definition of finite automata is defined by tuples, that is Q, sigma, Q naught, F, delta. So what are those notations? The Q is, capital Q is a finite set of states. Then what is sigma? Sigma is a finite alphabet of input symbol. Then what is a Q naught? Q naught is an initial state. It comes from capital Q, is also is in capital Q. So it's a subset of capital Q. What is F? F is a final set of the final state or a set of accepting states, because there is a, why do you call this a set of accepting state? So any finite automata can have more than one final state, right? So that is also subset of capital Q. Then finally there is a one more notation called delta. Delta is a function from Q cross Q sigma to Q, Q cross sigma to Q. This is called transition function, is also called as a transition mapping. Then how to represent this interpretation of Q cross sigma to Q is, for any element of Q of capital Q and any symbol A from sigma, we interpret like this: delta of Q comma A, small a. as a state to which the finite automata moves. If it is in state q and receive the input small a. This will be the definition of finite automata or finite state machine. So overall summary of this is which can any finite automata or finite state machine represented by phi notation. So that q, sigma, q naught, f, delta. Then we'll see the best example of finite automata. So in this case, as you told right in the previous slide, so that is finite automata, it is represented by phi notation and is represented by capital M. Okay. So now have what is capital Q is a finite set of state. It could be small q naught, q1, q2. Then what is the input? It may be 0 and 1. So what is q naught? Is an initial state. What is f q2? Then what is a delta? Delta it is a transition function, is nothing but q cross sigma to q. So how do you represent this? You have to represent it by the transition diagram and transition table. Look at this. There are capital Q have 3 states, q0, q1, q2. I have taken this. States can be represented by circle. I have taken these 3 circles. Each of them are labeled by q0, q1, q2. Okay. Let us see why this is RO as for q0. Since this it indicates that it is a initial state. Okay. So now how do you represent delta? Delta as definition is delta as q cross sigma, right? Q is set of these state. So q state with respect to input. Input is with us, it is input is 0 and 1. So I start with the q naught. Q naught on 0, it go to q1. So look at like this. Okay. Then q naught on 1, it will go to q naught. So look at this. Right. So what is the next state? Q naught on 0 and 1 is over. Let us move on to the q1. So q1 on 0, it will go to q2. q1 on 0 will go to q2. Look at this. So q1 on 0, it will go to q2. Then q1 on 1 will go to q0. So look at this. This is q1 on 1 will go to q0. What is this q1 state is over. Go to the next state is q2. q2 is q2 on 0, it will go to q2. Then q2 on 1 will go to q0. This now it is complete finite automata. So what is this? Double circle is indicated. It is a final state or accepting state. This will look at the f is equal to q2. So this way can represent either in the transition table. This table is called as a transition table. This diagram is called as a transition diagram. Okay. So now informally, so as you explained in the previous slide, a state diagram that comprehensively capture all the possible state and transition that machine can take while responding to the stream or sequence of input symbol is nothing but regular language. Right? So this good regular language can be represented either through deterministic finite automata or DSM or DFA. That means what is a definition of DFA? Machine can exist in only one state at any given time. So that means machine can have a transition on every input. So not a multiple transition. Every state, every input, there is only one transition. There is no multiple transition. That is the meaning of this definition. So whereas in another machine called non-deterministic finite automata or non-deterministic finite state machine, that is the definition, machine can exist in multiple state at the same time. That means machine can have a multiple transition for every input. So it may or may not be, right? But it can exist multiple transition. So the definition of deterministic finite automata is similar to the simple finite automata, but so as we have discussed in the previous slide couple of minutes before, is a finite set of state. Again I will recalling this, all this notation, phi notation. The sigma is a finite set of input symbols, start state, set of accepting state, and transition function. That means q cross sigma to q, right? So as you told, this is defined by the phi tuple. As you all already aware of this notation, what exactly definition of these notations, right? Better understanding the deterministic finite automata through the best examples. I'll start with an example like DFA accepting a string 0 1. That means any string is generated by given regular language which contains always 0 1. That means he has not setting it a condition. This either it can be at the middle or at the beginning or at the end, but it should contain 0 1. How do you represent, as you told, so that any DFA or NFA can represent by transition diagram or transition table. Okay, in this case I'll take the transition diagram. Look at this. I'll always start with the start date Q0. So what is the basic string in this? 0 1. So basic string, any DFA string containing 0 1. So now on 0, Q0 on 0, it will go to Q1. Then so now at that moment you are at Q1. Q1 on, again what is the next input in this case is a 1. So Q1 on 1 will go to Q2. Now this basic string is over, but prior to this it could have any 0 or 1. After that also it can have 0 or 1 any number of times, right? So let us come back to the Q0. Already Q0 on 0, it will go to Q1. What is missing it? It is missing the transition on 1. So you have to give that, right? So which you can accept it after accepting a 0 1, accepting it, right? Now as you told that it can complete the state on Q0 by accepting a 0 and 1. So let us move to the Q1. So Q1 already have transition on 1, but what is the missing transition is 0, right? So 0, but look at that, it can have a 0 transition over Q1 itself, right? So because even it can be take the 0 0 and 1, it containing 0 1. Let us move to the next state. So that is the next state is Q2. Q2 is already have the 0 comma 1, which accept it. This entire transition diagram, it can be represented by these tuples. What is the tuples here? 5 tuples, as you told. This is Q, Q0, Q1, Q2, and sigma is 0 and 1. Start state in this case Q0, final state in this case Q2. Transition table will be represented like this. That means transition table is nothing but a transition function which Q cross sigma to Q. So Q cross means set of state versus input symbol. What are the input symbol? Q0 on 0, it will Q0 on 0, it will go to Q1, Q0 on will go to Q0 itself. Like that it will remaining of the state. So in a transition table, final state is represented by star, okay, and initial state is represented by arrow. So what makes this DFA deterministic? That means, what did you understand from the previous slide? What is the definition? The machine can exist only one state at every input, right? There is no multiple transition. That means every state have a single transition for every input. Look at, there is a on 0 have only one transition, on 1 have only one transition. It will not go to the multiple state. So like that remaining state also will be have a single transition for every input. That is the meaning of deterministic finite automata. Okay, what if the language allows the empty string? Then if at all it allows the empty string, that means it is not a DFA. Okay, so then what is the language accepted by this DFA? Which accepted by DFA 0 plus 1. That means plus indicate here either accept any number of zeros and ones, right, followed by a string containing 0 1 and followed by any number of zeros, either zeros or ones, okay, including epsilon. That means epsilon here is not representing it in terms of DFA. Okay, let us move to the next complicated problem. Will be demonstrated how that can be constructing DFA, right? So look at that. The statement will be like this: construct a DFA which accepts a set of all string of zeros and ones having at least 3 consecutive zeros. 3 consecutive zeros is important point of this problem statement. In this case, I need to construct a DFA. What is that? It accepts all zeros and ones. It is a input alphabet, but condition is that it should, any string is generated from that input alphabet, it should at least contain 3 zeros. Then let us point out what is the minimum string is required. Minimum string is required is 3 zeros, right? So 3 zeros it required. Look at this. 3 zeros I have written here. 0 0 0. So that will be the minimum string. Then for that you have to construct a minimal DFA for it. Basic string first you have to construct it. I'll take the, as you told, that is state is represented by circle, and that will be the initial state. So first it is on the Q naught. First here it is the first state is will be the initial state. On 0 it will go to the next state. It will go to the next state. It will go to the next state, that is 0. Again, what is the next input here? The next input also 0. So that I'll accept it 0. Again it will go to the next state. So that is finally we have one more 0. That also will be go to accepting 0 on, will go to the next state. Then in order to make these 3 zeros are accepting it, the final circle should be double circle. That will be the accepting state. Now this minimal string, it is 3 zeros, it make that is a DFA, it is accepted. It is accepted. Let us see next possible string. What is the next possible string? 1 0 0 0, right? So anyway it is having a at least 3 consecutive zeros. Before to that it can have any number of ones, right? Any number of ones. Then again you have to start with the initial state. It can have any number of ones at beginning, right? That will also made it accept it. What is the next possible string? Look at this. It may be 0 0 0 1. So it is already start from the initial state. 0 is there, 0 is there, 0 is there. It is go to the accepting state. But we have still input buffer, have one more. 1 is there. So that you have to made it accepting it. So because you already achieved the 3 zeros, so at the end you have to accepting 1, right? It can comes any number of ones at the end, right? So that also accepted, right? But you may not know any combination, it can comes in between the this 4 state, right? Let us see the next possible string. So this also it's a valid string because it is contains a 3 consecutive zeros either at the beginning or at the end or at the middle, right? Look at this. This also it is a valid string. You have to made it accepting it, right? So there is already we have started with a 0. We have a transition from the start state. All the 3 0 accepted. Go to the 4th state. We have a one more 0. So it can be ended with already. So any number of 0 at the end, right? Right? So it can have a one more 0 at the over the loop on 4th state. Okay, so this is also possible because this string also has a 3 consecutive zeros. Let us see that already 0 has come. Okay, we have a 0, but already we have a transition from the initial state 0. Go to the next state, we have a transition 1, but the state 2 you are not having a transition on 1, so we have to create it. If you create the transition on the state 2 itself, it will accept even it is a 2 consecutive 0, but so that should not create here it is wrong DFA, so that is you have to come back to the start state. Now again 3 zeros will be achieved. Let us see that another possible string. This also valid string, right? 0 0, but there is once you reach after 2 zeros, third state, we have a one more transition 1, but here it is have a 0 transition is there, 1 is missing it. Again you have to come back on 1 to starting state, okay. Let us move to the next transition, so on that. So look at that. How do you ensure that all the possible string is accepting every state have a transition on every input? Let us take the first state of initial state, have a transition on 1 and 0. Look at the second state 0 and 1. Look at the third state 0 and 1, and the fourth state also have a 0 and 1. So that means every state have a transition on every input, then it is complete DFA. It is accepting the any number of zeros and ones having at least 3 consecutive zeros. I hope that you understood this problem. So let us see how do you demonstrate that. So all this first string can take that. I will be animated a sum of this string, whether it is a be transition it, okay, tracing it. I will take 3 zeros here. I'll start with the starting state. First on 0 will go to the second state, then 1 0 you have consumed it, then we have a 2 more zeros. At that time you are at the second state, then again we'll move on to the third state of on 0, then we have only 1 0 at the moment or at the third state. Again there is a one more transition from third state to fourth state, there is a 0. Now at that moment all the zeros are over, you are at the accepting state, then it is a given string accepted. Let me will take one more a better understanding. Will say animating one more string. I'll take here 0 1 0 0 0, right? First of all it is 0 has come, 1 0 is over, right? There is a 1, I have a 1, right? 1 is also accepted. At the moment you are at the beginning state, then on 3 more zeros are there, that will be the linear case. It will all zeros accepting it. Look at it, right? So how that will be processing here. Now that also accepted. With this I hope you that clear understanding of this problem. Is there any doubt? Please comment this, okay? Which is at, if you complete that diagram, writing it is enough to get the full marks of it? No, you have to be complete the rest of the M description. What is DFA? It is DFA defined by 5 tuples, that is denoted by M, Q, sigma, Q naught, delta, F. Then you have to describe them with respect to this diagram. So what is Q here? So Q has Q naught, Q1, Q2, Q3. Then sigma is 0, 1, and Q naught belong to Q is a start state. Then F is a Q3 is a subset of capital Q. Then Q cross sigma to Q is a transition function. Then that will be represented in transition table. Look at that. As you told, that is a final state is represented by star, Q3 is the star, right? So then here it is, you can final state is this, initial state will be arrow mark, okay? So this is the one best example. Please, any doubt have to be comment, right? Thank you.